standard speed down 3.5. 47 forward. Put up. On 1.5 down. Tranquility Base here. The Eagle has landed.
Hello and welcome back to the channel. Today we'll be focusing on the moon and I will show you how to find the Apollo 11 landing site with an affordable telescope and setup. Before we dive into the details of the Apollo 11 landing site, let's briefly talk about the equipment and the setup I used for these shots. I've been using the Celestron Maxitov 127 SLT telescope with a focal length of 1500 mm and therefore a high magnification. Initially I used it with a cheap Canon EOS M50 camera. This affordable setup allows you to make really cool looking images and videos of the entire moon demonstrated by this footage. Now onto the exciting part. How do we locate the Apollo 11 landing site on the moon? Here are some geological lunar hallmarks. The Apollo landing site is located in the Mare Tranquillitatis, the Sea of Tranquility, around here. To see even more details, I used this cheap, dedicated planetary astro camera. As we zoom in closer, we see these distinct craters and terrain features. Aldrin, Collins, Armstrong, and of course the landing site. Here you can see the actual footage I captured with my telescope and a cheap DSLR camera. Let's zoom in to see even more details. Here you also can see the craters Ritter and Sabine. Still a little blurry, but with some software work we can get even more details from that. I'll show you how. We definitely need a sharper image. My best results I got from stacking only high quality frames, drizzle 1.5-fold, and sharpening with Registacks and Blur Exterminator. And here's the image with the highest level of detail of the Apollo 11 landing site region I could get during this imaging session. And most probably I will try again, so stay tuned and subscribe to my channel. Let's zoom in here. Let's get an idea about how big those lunar structures actually are. You will be surprised. Aldrin and Armstrong are approximately 4 kilometers in diameter or 2.5 miles. Collins is about 3 kilometers in diameter or 1.9 miles. Now we have a sharpened and detailed image of the Apollo 11 landing site region. Let's compare it to a reference image and align. Let's see what we have. I'm sure you can already see some similarities here. We have those elongated structures here. And some other similarities depicted as arrows. Moltke crater and this elongated structure here. Now let's align those images against each other. You can clearly see Ritter, Sabine, Moltke and other structures. Let's zoom in again. Again, you can see the elongated structure depicted as a red line here. Let's take the same distance here. And this is about the Apollo 11 landing site region in detail. Let's try another zoom to confirm this location. Okay, let's have a break. Let's just assume for a second we would be able to see smaller structures of the Apollo 11 landing site. What would we actually see? Among the stuff the Apollo 11 crew left behind, the biggest structure by far would be the lunar module. Here's a drawing of the lunar module, or LM. The lunar module is approximately 4.2 meters or 14 feet wide. But we would not see the entire eagle itself, but only the leftover bases, as seen from the Apollo 17 camera.
Proceeded, 3, 2, 1, ignition.
This is the lunar module left over on the lunar surface. But of course, as observers from the Earth, we would not see it from this angle, but from the top. The longest distance is 9.45 meters or 31 feet. The smallest diameter is 4.3 meters or 14.1 feet. And just for the people who are interested, the height is about 5.8 meters or 19 feet. Let's do the image alignment against the reference image. Here we have the Aldrin and Collins crater. The diameter of the Collins crater is approximately equal to the length of the Golden Gate Bridge. Here we have an approximate scale, and around here is the Apollo 11 landing site. On the left top again we have Aldrin, on the right top we have Collins, and the other bright region left from the red arrow is Sabine C, also a crater, with approximately 3 kilometers diameter. To stick to this picture and this comparison, finding the lunar module would be equal to find a really big car on the Golden Gate Bridge. And this is really just not possible with this setup. What would be necessary to see structures on the moon which are about 4 meters or 13.1 feet in size? Let's do the math. This is a huge telescope size, far beyond what currently exists on Earth. To give you some perspective, there's a satellite orbiting the moon, and a few years ago this satellite made some images of the different Apollo landing sites. Really cool stuff. Conclusion. So yes, it's possible to get an idea about the Apollo 11 landing site structures with this setup, but it's really just not possible to resolve this area at all with this setup. It's just not possible. But I think we were able to get really nice lunar images and detailed images, and I hope you had fun and maybe learn something. And I think it's really interesting and gives you maybe a new perspective about how big the moon actually is. So thank you for watching and see you next time. Clear skies.